Assalamu alaikum, dear students. Today our topic is integrated rate expression of the first order reaction. Now, what is a first order reaction? A reaction is said to be first order if the rate of reaction depends upon only one concentration term. तो उस रिएक्शन को फर्स्ट ऑर्डर रिएक्शन कहते हैं जिसमें रेट ऑफ रिएक्शन जो है वो डिपेंड करे सिर्फ एक कंसंट्रेशन टर्म पर. फॉर रिएक्शन A gives product or 2A gives product. For reactions A it is single reactant, it gives product, or 2A gives product. Rate of reaction depends is proportional to only A. And अगर हम for a reaction in which we have two reactants, A plus B gives product, rate of reaction is proportional to either only A, reactant A, or B. So we will take a simple case. In all these reactions, the rate of reaction depends upon one concentration term. Either it depends upon A or B, we can determine the rate of reaction, or rate of reaction depends upon, in case of the 2A, only A raised to power 1. Similarly, if A gives the product, rate of reaction is proportional to the concentration of the reactant A. Now we will take the simplest cases, that is A gives product, and we will derive the expression, integrated rate expression for the reaction. So for the simplest case, A gives product, for a simplest case, A gives product. So we will derive the expression for the rate expression. Let the initial concentration of A, the substance A, is A moles per liter. So initially we are taking A moles per liter of the reactant A. Let after time t, it can be t minutes, of time t has different values, the concentration of A is x moles per liter, or after time t, let x moles per liter of A has decomposed. Initially we have the substance A and our the initial concentration of this A is A moles per liter, and after time t, x moles of this A or the substance A has decomposed, and after time t the concentration of A is now A minus x moles per liter. That is, we have A gives the product. Initially we have, for this substance A, we have A moles per liter of it, and the A moles of the substance A undergo the reaction and they decompose and form X moles of it now decompose and form the product after time t. So after time t, how much of the A, which is equal to A moles per left, is A moles per liter is left, that is A minus X. क्योंकि initially we have A minus A moles per liter, X moles इसके decompose हो गए, तो अब after time t A का कितना रहता है, that is A minus X moles per liter. According to law of mass action, rate of reaction that is dx by dt is proportional to the concentration of the substance A after time t, that is A minus X. Since X is the concentration of the product and the concentration of the product go on increasing, therefore the change in the concentration of the product with respect to time, that is dx by dt, determines the rate of reaction. It is proportional to A minus X, or dx by dt is equal to k A minus X, where k is the rate constant or specific reaction rate. Now we can write dx bata A minus X is equal to k dt, integrating both sides. जब हम इसकी इंटीग्रेशन करते हैं, the integration of a1 by A minus X with respect to dx, k constant है, और we can write k dt. The integration of x, ये किसकी differentiation है, that is log of x or log natural x. Similarly, this is the log natural A minus X. Had it been A plus X, then log natural A plus X, but it is minus X. ये x का जो quotient है minus, वो यहाँ आएगा. So log n means log natural. A minus X is equal to k constant है, integration और differentiation वो ये cancel हो जाएगी, that is kt plus I, where I is the integration constant. For अगर हम टाइम 0 रखेंगे, for t is equal to 0, तो A का जो इनिशियली A मोल्स पर लीटर थे, जब टाइम 0 है, how much is the value of X? So X is not the format. X is the portion of the A, it is the quantity of A which gets decomposed when the time is 0, so we don't form the product. So at time t is equal to 0, x is equal to 0, putting the value in equation first, ये हम equation first रखेंगे, we get minus log natural A minus x is 0 because t is 0, so log natural A is equal to k into t is 0, that is 0, k into 0 is 0, is equal to I. So I is equal to minus log natural A. Putting value of I in equation first, हम equation first में substitute करेंगे. So the equation first will become equation first क्या बनेगी? We have this equation first. This is minus log natural A minus x is equal to kt, and instead of I we now have minus log natural A. Minus log natural A. log natural A को इस साइड ले लेंगे, log natural A minus log natural A minus x is equal to kt, or we can write it like this, kt is equal to log natural A minus log natural A minus x. Kt is equal to log natural A minus log natural A minus x. Log natural A minus log natural A minus x is just like log A or log m minus log of n. We have the formula. Log of m minus log n is equal to log of m minus n. Similarly, log of A, that is log m divided by log n. Log m minus log n, log m by n is equal to log m minus log n. Similarly, if we have log natural m divided by n, that is equal to log natural m minus log natural n. So for log natural m minus log natural n, we can write log natural m by n. So instead of m we have log a, instead of n we have a minus x, so it will become log natural m minus n, that is m divided by n. So for m we have a, for n we have a minus x, that is equal to kt. Or we will remove the log natural with, first we will write the value of k will now be equal to 1 by t log natural a divided by a minus x. We will substitute, we will remove this log natural by logarithm. So while writing, changing logarithm natural into logarithm, we have to multiply it by 3 not 3 divided by t. This will become log of a divided by a minus x. This is equation 2. This is the integrated rate expression for the first order reaction, or this is the rate constant for the first order reaction. We can also write this equation if instead of a moles per liter, we have a naught is the initial concentration of the substance A. If a naught is the initial concentration and A is the concentration of reactant after time t, then equation second can also be written as, तो अगर हम जहाँ पर पहले हमने A moles per liter लिए किसके, the substance, when we write A gives product, so what is the initial concentration of A? We denote it by A naught, and this A in the long bracket is the concentration of A after time t. So for small a we write A naught, and for A minus x we write A. We will substitute the values in equation second. The equation second can also be written as K is equal to 2.303 divided by T log of, instead of A we have A naught divided by, instead of A minus x we have the concentration of the reactant A of the substance A after time t is A in the bracket. So equation third. So equation second and third are the rate expressions for the first order reaction, or we can write the rate constant for the first order reaction is equal to K 2.303 divided by T logarithm A, which is the initial concentration of the substance A, divided by A minus X, the concentration of the substance A after time T. Similarly, we have K is equal to 2.303 divided by T log of A naught. A naught is the initial concentration of the substance A, and A in the long bracket is the concentration of the substance A after time t. So these are the two expressions. Now characteristics of the first order reaction. Characteristics of first order reaction. So ये दो इक्वेशन मैं यहाँ पर लिखूँ 2.303 डिवाइड बाई टी लॉग ऑफ A डिवाइड बाई A माइनस x, और K is equal to 2.303 divided by T log of A naught divided by A. This is equation second, this is equation third. Now, what are the characteristics of the first order reaction? So, any reaction of first order, any reaction of first order must obey equations second and third. Equation third can also be expressed as, so K is equal to 2.303 divided by T. Again, this is log of M divided by N. That is equal to log M minus log N. That is log of A naught minus log of A. Cross multiplication, that is KT is equal to KT divided by 2.303. क्रॉस मल्टीप्लिकेशन टी यहाँ आएगा, इसको डिवाइड यहाँ करेंगे, ये डिनोमिनेटर में आएगा, सो के टी डिवाइड बाई 2.303 इज इक्वल टू लॉग ऑफ ए नॉट माइनस लॉग ऑफ ए, और लॉग ऑफ ए, ये माइनस है, ये यहाँ ले लेंगे, ये प्लस बन जाएगा, तो यहाँ पर के टी डिवाइड बाई 2.3 ये लेफ्ट साइड में है, ये राइट साइड में ले लेंगे, माइनस के टी डिवाइड बाई 2.303 तो ये माइनस प्लस लॉग ऑफ ए नॉट, इक्वेशन 4। तो अब अगर हम इक्वेशन 4 ले लेंगे, the log A, the concentration of A is the concentration of the substance A of time t. So the value of this log A goes on changing with respect to the time. K is the rate constant for first order reaction. This is constant. T varies. We can change the value of the time. 2.303 is also constant. Log of A naught, initial concentration of the substance A, that is also a constant quantity. This is constant, this is the variable, only T is the variable, this is the constant, this is the variable. So the equation 4th is just like the equation of a straight line. What is the equation of the straight line? Y is equal to mx plus c. This is y, this is log a, which is variable. M is the slope, that is, which is constant, which is equal to minus k divided by 2.303. X is the variable, t is the variable, c is the constant, log a naught is the constant. So if log a, which is the variable, is plotted versus, अगर इसको हम प्लॉट करेंगे versus time, we must get a straight line, because it is just like the equation of the straight line. Y is equal to mx plus c, which is a straight line. तो अगर हम प्लॉट करेंगे, this is the value of, we will plot the value of log a, the variable which we will take along the y-axis, again is the time t, we get a straight line. The intercept, this is the y-axis, this is the x-axis, the intercept on the y-axis, the intercept on the y-axis, that is the axis that denotes the values of the log a. The intercept, जहाँ पर ये ग्राफ इस लाइन को intercept करेगी, that is this point, it will determine the value of is equal to, will give us the value of the intercept on the y-axis, will give the value of, किसका वैल्यू ये देगा, that is log of a naught, log of a naught, and the slope. तो जब हम इसका स्लोप निकालेंगे, तो here which is the slope, that is mx plus c, c का वैल्यू हमें निकला, that is the intercept on the y-axis. Now slope here in the equation of the straight line, y is equal to mx plus c, अगर हम इसके साथ कंपेयर करेंगे, the value of the slope is equal to minus k divided by 2.303, and the slope is, will give us the value of minus k divided by 2.303. So by plotting the log A versus the time, we determine the values of the log of A naught and the slope, that is minus k divided by 2.303. From the slope, value of the slope, we will determine the value of the rate constant, that is k for the first order action. Now the second characteristic is half-life period. Now half-life period. This is second characteristic. Half-life period. So what is the half-life period? Half-life period of first order reaction is the time in which the concentration of reactant is reduced to half of its original value. So for T is equal to for time T is equal to T half. अगर हम T half, how much is the concentration of the A left X, which is the concentration of the substance A. Initial concentration A gives product. Initial concentration of A is A moles per liter. After time T इसका X मोल्स जो है वो डिकम्पोज हो गए, तो आफ्टर टाइम T A का कितना रहता है, A माइनस एक्स. एज टाइम इज T हाफ, तो A X जो है that is at the half time period the X which gets decomposed, which is will be equal to A, the initial concentration divided by 2, that is the half of the reactant has decomposed. So the reaction rate constant equation becomes 2.303. Instead of T we have T half log of A divided by, for A minus X we will substitute A in this equation. यहाँ लिखेंगे substituting values of time as T half and X equal to A by 2 in the equation below. So K is equal to 2.303 divided by T half log of A divided by A minus X. A minus X is A minus A by 2, cross multiplication, 2A minus A divided by 2. दो A में से A निकालेंगे A by 2. So A minus X is equal to A divided by 2. इसका वैल्यू हम लिखेंगे A divided by 2. हमें T half का वैल्यू निकालना है, क्रॉस मल्टीप्लिकेशन T half is equal to 2.303 divided by K log of, this is A whole divided by A by 2, that is A into 2 by A. A cancel, that is 2.303 log of 2 divided by K, that is T half. Now half-life period is equal to From the logarithm table, we can determine the value of log 2, which is equal to log of 2 is equal to 0.3009. While substituting the value in the above equation, we get 2.303 divided by k. Log 2 का value है 0.3009. So जब हम इनको मल्टीप्लाई करते हैं, that will be equal to 0.693 divided by k approximately. So the half-life period of the first order reaction is equal to 0.693 divided by k. Since it is independent of the initial concentration, so the half-life period does not depend here upon the initial concentration, it depends upon the rate constant. It is inversely proportional to the rate constant. So this was the second characteristic. Now the third characteristic is unit of rate constant of first order reaction. From the above equation, we can write k is equal to 0.693 divided by t half. It's again the rate constant is independent of the here. Again, rate constant expression, first, second, third, fourth, this is fifth. Here in this equation, there does not exist concentration term. So how much will be it is, what will be its unit? That is, this is constant, time is, इसको लिखेंगे 1 divided by time, that is time inverse. So the unit for the rate constant is in SI unit. We express time in seconds, so this is second inverse or S inverse, or it can be sometimes minute inverse. So this is the unit, SI unit for the rate constant of the first order reaction. So these three are the characteristics of the first order reaction, in which we have derived the integrated rate expression. Also we derived the expression for the half-life period, and again we derived the unit for the rate constant of the first order reaction, that is second inverse. Thanks.